どうも、勝手に電力2.0で見始めたいと思います。今日989回目ということで、まずは結局このヒートポンプみたいなところが、この需要から作っていく。今、その出力抑制というところで発電からやっぱり始まると、発電の伸びるスピードの方が速くなってくるので、そういう意味では需要を先に作ってからそこに発電を合わせていくみたいな時代が、やっぱり先出しっていうのは結構重要なんじゃないかなと。もちろん日本はもう発電の方が始まってしまっているので、発電をこれを需要どうやってついていかせるかみたいなところで、ヒートポンプっていうのは一つのヒントになってくるのかなと思うので、IEA のですね、この The Future をヒートポンプっていうところを少し見ながらですね、世界の動向と日本はどういったやっていって、このヒートポンプって特に産業としても強いので、このあたりをなんとかできないかなというところは一つヒントが出ればいいかなと思っています。Heat pumps are a proven way to provide secure and sustainable heating. Heat pumps powered by a low emissions electricity are the central technology in the global transition to secure and sustainable heating. Heat pumps currently available on the market are 3 to 5 times more energy efficient than natural gas boilers. They reduce households' exposure to fossil fuel price spikes, which has been made all the more urgent by the ongoing global energy crisis. Over one-sixth of global natural gas demand is for heating in buildings. In the European Union, this number is one-third. Many heat pumps can provide cooling too, which eliminates the need for the separate air conditioner for the 2.6 billion people who will live in regions requiring heating and cooling by 2050. Heating in buildings is responsible for 4 gigatons of CO2 emissions annually, 10% of global emissions. Installing heating pumps instead of fossil fuel-based boilers significantly reduces greenhouse gas emissions in all major heating markets. Even with the current electricity generation mix, an advantage that will increase further as electricity system and decarbonize. Around 10% of space heating needs globally were met by heat pumps in 2021, but the pace of installation is growing rapidly. The share of heat pump is comparable to that of fuel oil for heating and of the other forms of electric heating, but lower than the over 40% of heating reliant on gas heating and 15% reliant on direct heating. In some countries, heat pumps are already the largest source of heating. In Norway, 60% of buildings are equipped with heat pumps, with Sweden and Finland at over 40%, undercutting the argument that heat pumps are unsuitable for cold climates. Global sales grew by nearly 15% in 2021, double the average of the last decade. Growth in the European Union was around 35% and is slated to accelerate further in light of the energy crisis, with sales in the first half of 2022 roughly double over the same period last year in Poland, the Netherlands, Italy, and Austria. China continues to be the largest market for new sales, while North America has the largest number of homes with heat pumps today. Together, these regions, along with Japan and Korea, are also major manufacturing hubs, home to the industry's largest players. Government energy security concerns and climate commitments would make heat pumps become the primary means of decarbonization space and water heating. This report explores a scenario in which governments around the world meet all their announced energy and climate-related commitments in full and on time. As the proven technology of choice to decarbonize heating, global capacity of heat pumps jumps from 100 gigawatts in 2021 to nearly 2,600 gigawatts by 2030. In this scenario, boosting their share of total heating needs in buildings from 1/10 to nearly 1/5. As a result, natural gas demand falls by 80 billion cubic meters, and heating oil drops by 1 million barrels per day, and coal declines by 55 million tons of coal equivalent. In aggregate, this means heat pumps account for nearly half of the global reduction in fossil fuel use for heating in buildings by 2030, with the remain coming from other efficiency measures in a scenario consistent with the global climate target of 1.5 heat pumps accelerate faster. Their capacity nearly tripled by 2030, and their share in heating reached 1/4. Heat pumps can also address heating needs in industry and district heating. Large heat pumps can provide heat up to 140 to 160 today, with higher temperature possible through innovation and improved designs. The most common industrial heat pumps today provide lower temperature heat. The paper, food, and chemicals industries have the largest near-term opportunities, with nearly 30% of their combined heating needs able to be addressed by heat pumps. In Europe alone, 15 gigawatts of heat pump could be installed in 3,000 facilities in these three sectors, which have been hit hard by recent rise in natural gas prices. Heat pumps contribute to cutting gas imports quickly, especially in Europe. The potential for heat pumps to cut dependence on natural gas for heating is particularly large in the European Union, where natural gas is the most used heating fuel and where gas prices have risen the most. In a scenario consistent with the EU's climate ambitions, heat pump sales rise to 7 million by 2030, up from 2 million in 2021, helping achieve the REPower EU objective of ending Russian gas imports before 2030. This deployment reduces the consumption of natural gas by 7 BCM in 2025 and 21 BCM by 2030, an amount equivalent to almost 15% of EU pipeline imports from Russia in 2021. Retrofitting buildings in parallel reduces the strain on the power sector. The accelerated deployment of heat pumps inevitably increases global electricity demand, though energy efficiency and demand response measures can greatly reduce the impact on power systems. The share of electricity in heating for buildings and industry doubles between 2021 and 2030 to 16% if climate pledges are met. Over that same time, global electricity demand rises by 1/4, to which heat pumps contribute less than 1/10. For households that added a heat pump without improving efficiency in parallel, this can nearly triple their peak demand during winter, improving a home's efficiency rating by 2 grades. Example from D2B in Europe countries can help heat energy demand and reduce the size of the heat pump needed, saving consumers money and reducing the growth in peak demand by 1/3. Together with careful grid planning and demand-side management, this moderates the needs for distribution grid upgraded causes by electrifying heat and minimize the need for additional flexible generation capacity to 2030. The accelerated development of heat pumps brings a range of benefits. Over their lifetime, heat pumps can save consumers money and shield them from price shocks. The average household or business that use a heat pump spends less on energy than those using a gas boilers. These savings offset the higher upfront costs for heat pumps in many markets today. In some, even without subsidies, the economic proposition of heat pumps improves in the context of today's energy price spikes. Household savings range from USD 300 per year in the United States of USD 900 in Europe. With appropriate support for poorer households to manage the upfront costs, heat pumps can meaningfully address energy poverty, with energy bill savings in lower income households ranging between 2% and 60% of their household income after moving away from the natural gas boiler. Switching to heat pumps cuts emissions of green gases and helps improve air quality. Accelerated deployment of heat pumps in line with natural climate targets can reduce global CO2 emissions by 0.5 gigatons already by 2030. However, unintended leaks of F-gas, refrigerants, potent greenhouse gases can decrease their positive climate impacts. With today, refrigerants, heat pumps still reduce greenhouse gas emissions by at least 20% compared with a gas boiler. Even then, running on emission-intensive electricity, this reduction can be as large as 80% in countries with cleaner electricity. Global emissions of major air pollution caused by combustion heating in buildings also drop, particularly from coal in China. While other hazards associated with heating by fuel combustion diminish. The expansion of heat pump manufacturing and installations to meet rising demand would create more jobs. Global employment in heat pump supply nearly triples to over 1.3 million workers to 2030 in our scenario. Jobs in installation grow the most, with growth also in maintenance and manufacturing providing numerous opportunities, especially for medium-skilled workers. Action is needed to overcome barriers to faster adoption. Accelerating the take-up of heat pumps requires overcoming a number of barriers. Chief among them are the higher upfront cost of buying and installing the device relative to other heating options, other non-cost deterrents to consumer adoption, manufacturing constraints, and potential shortages of qualified installers. Concerted action by governments in partnership with the heat pump industry is needed to address their hurdles and achieve higher rate of deployment. Despite long-term savings, high upfront costs can deter consumers. The cost of purchasing and installing an air-to-air heat pump is typically between USD 3,000 and USD 6,000. However, even the cheapest air-to-water models, including modification to the existing radiator systems, remain 2 to 4 times more costly than natural gas boilers in most major heating markets. Financial incentives are currently available in over 30 countries around the world, covering more than 70% of today's heating demand. The subsidies in these countries make the cheapest heat pump options comparable to the cost of the new gas boiler for consumers. Additional incentives can target low-income households, as in Poland, and or high-efficiency model as in Canada. In some countries, the design of electricity tariffs and energy taxation put heat pumps at disadvantages relative to fossil fuel boilers. Tariffs and taxes should instead be titled in favor of cleaner and more efficient consumer choices. A number of non-cost barriers hold back consumer adoption of heat pumps today. These include lack of information, spirit incentives for building owners and tenants, and building regulations. Several governments have taken action to adjust building codes, such as in the Code Republic, create one-step shops for consumers, such as an island, and encourage alternative business model to address the spirit incentive. Notably, in North America, the United Kingdom and Germany, though stronger efforts are required. Particular attention needs to be paid to addressing barriers to the installation of heating pumps in multifamily and commercial buildings, which account for a low share of sales today. Shortages of qualified installers already a bottleneck in many key heating markets. Call for large-scale worker reskilling. Global demand for full-time installer quadruple by 2030 in our scenario. Incorporating heating pumps into existing certifications for heating technicians, plumber, and electrical engineer who have similar skill, who help reduce training requirements. Financial incentives such as those used across Europe can also attract new workers to specialized training programs. The government needs to work with industry to lower supply side hurdles. Leading manufacturers have recently announced plans to invest more than $4 billion in expanding heating pump production capacity and related efforts, mostly in Europe. New heat pump installation in the next 4 years would be roughly equal to the number of heat pumps installed in the last decade. Several countries, notably the United States, are responding to supply chain vulnerabilities with incentives to build up domestic manufacturing capacity. Long-term policy consistency and regulatory certainty, together with targeted action to strengthen the supply chain, remain critical for manufacturers as they consider where to expand their operations. In particular, regulations on F-gases must balance the need to limit refrigerant emissions with cost, safety, energy, efficiency, and supply chain considerations. Accelerating deployment of heat pumps in line with national climate target is well within reach, but requires further efforts from policymakers and industry. The market growth in heat pumps needed this decade to hit national climate target is not as steep as the expansion we have already seen in solar PV and electric vehicles. Also, there would need to be a further acceleration to get on track on the IEA's net zero emission by 2050 scenario. The additional upfront investment required is sizable, reaching USD 160 billion annually by 2030. But these incremental costs are outweighed by economy-wide savings of fuel, especially if today's high price persists. Governments and industry have vital roles to play to address persistent market barriers and enable heat pumps to play their full part in addressing today's most pressing issues: energy security, energy affordability, and rapid reductions in emissions.